Section 7.1 is called Completing the Square. The objective here is to solve quadratic equations by using the completing the square method. Now let's take a look. So far we've learned how to solve some quadratic equations, and specifically those that can be factored into some form of quantity x minus p times the quantity x minus q equals 0. And those that are in the form of x squared equals some number by just taking the square root of both sides. So we've taken a look at those types of equations. Let's look at some equations that have to be solved by another method. They're not factorable, and at the same time, it's not just simply x squared equals some constant. So example 1, part A, we'll take a look at this one. It says the quantity x minus 2 squared equals 3. Now, it might be tempting at first to multiply out the left-hand side and FOIL it, x minus 2, and then move the 3 over and solve. And that is one way to approach the solution here, but an easier way would be to take a look at the fact that this left-hand side is squared. So we could simply take the square root of both sides to get this alone. So let's square root both sides to start, making this x minus 2 equals plus or minus the square root of 3. And remember, when you're solving an equation and you're taking the square root, you have to look at both the positive and negative roots, or both conjugates in a sense. And then simply add 2 to both sides. Well, how would I write plus or minus 3, or plus or minus radical 3, and then plus 2? The way to write it is putting the 2 in the front, and then put plus or minus radical 3. And you'll see that the answers, or the roots of this equation, are binomial conjugates. 2 plus radical 3, 2 minus radical 3. In part B, we're going to go ahead and take the square root of both sides to start, giving us 2x minus 5 equals plus or minus the square root of 8. Remembering that the square root of 8 is really radical 4 times radical 2. But radical 4 is really 2, so this becomes 2 radical 2, really. And that still equals 2x minus 5. Then next step, let's add the 5 over, leaving behind 2x, and this 5 just goes in front. Even if you were to subtract 5, so let's say hypothetically speaking this was a plus 5, you would subtract 5 by putting a negative 5 in front here. You're always going to put this number in front because the plus or minus has to come afterward. Now in this case we have to divide by this 2 still, so let's divide both sides by 2. This is going to give me 5 halves plus or minus, and this is really now just going to be 2 halves root 2. But 2 halves is just 1, or that just goes away. So your answers are 5 halves plus or minus radical 2. And again, our answers in this case are binomial conjugates. Notice, to get roots like this, clearly we were not able to factor the original equation. So going about that method of FOILing and then solving by setting the right-hand side equal to 0 wouldn't have proved to be anything worthwhile because it would not have been factorable in the first place. Part C says the quantity x plus 1 squared equals negative 4. And what we're going to notice here is that when we take the square root of both sides, when we attempt to take the square root of both sides, we should say we're going to have a negative. We're going to have a negative here. So for this problem, we take the square root, we get x plus 1 equals plus or minus the square root of negative 4. Now remember to think of negative 4 as really negative 1 times 4, so you're really just taking an I out here, like that. And this becomes a 2, so it's I times 2, or simply 2I. Final step is to subtract the 1 from both sides, and remember when we subtract the 1, let's do so it puts it in the front here, so we're going to input the 1 right there, thus giving us a final answer of x equals negative 1 plus or minus 2I. Noticing here that our answers are no longer binomial conjugates but complex conjugates because our roots, or our solutions to this equation, are imaginary. Finally, part D says x squared minus 4x plus 4 equals negative 5. And it might be tempting at first to add the 5 over, setting it equal to 0 in essence, and then trying to solve, but you can't factor what's left. There's no way to factor it. So let's go ahead and think about this. Well, we could factor the left-hand side to start as x minus 2, which is just the square of a difference in essence, x minus 2 quantity squared. And that equals negative 5. And now we can go ahead and take our square root. So we're going to have plus or minus the square root of negative 5. Well, there is no square root of 5, but we can take out the negative in there and make it I. So this becomes x minus 2 equals plus or minus I radical 5. Add the 2 to both sides, you're going to get x equals 2 plus or minus I root 5. Okay? plus or minus I root 5. And it's important to note in this last example that we took an equation that was written in standard quadratic form at first, and we're able to write it here as the sum or difference here with a square on the outside. And this is the key. The whole topic is called completing the square. Well, here's the square. So you want to be able to take an equation that doesn't look like it has a square and make it into something with a square like this. Well, the question becomes, what if this 4 wasn't a 4? What if this 4 was a 3? Well, then we'd have to add 1 to make it a 4, so we'd have to add 1 over here. So we'd have to figure out what we have to do to both sides of these equations to make this work. This is an easy example. Let's take a look at what we mean by that now. Example 2 says x squared minus 10x plus 3 equals 0. We could try to factor this, but we'll notice right away that it cannot be factored. So let's approach this problem like we did the last one. Let's move the 3 over to start so that we have it like this. This is what we had a moment ago. But in the last problem, we had a minus 4x and a plus 4 here, and it worked out with the minus 5 over here. Well, the question becomes, what number needs to go here so that I can factor this into the square of sums? Well, in this case, think about it. Last time I had a 4 here, right? And I knew that 2 plus 2 equaled 4, and 2 times 2 equaled 4. That's why that worked. Well, in this case, 5 plus 5 is 10, or negative 5 plus negative 5 is 10. Well, 5 times 5 will give us 25. So if we think about this, to make this a perfect square on the left-hand side, we need to add 25 over here, because that factors into x minus 5, x minus 5. Again, think of whatever this number is and what half of it is, and that's going to end up right here or right here. So if I add 25 there, though, I have to add 25 over here, making this a positive 22. So this equation becomes x minus 5 squared, that quantity equals 22. Square root both sides and add the 5 over. We get x minus 5 equals plus or minus root 22. Adding the 5 over, x equals 5 plus or minus radical 22. This is what completing the square really is, because we created this perfect square on the left-hand side. So you've completed, meaning filling in the blank, completed this to make it a square, or a perfect square. So let's write some general steps now for completing the square for something in the form ax squared plus bx plus c equals 0. So I'm going to write the steps or discuss the steps here as we actually go through the example itself. So let's say the example started as the following. 2x squared minus 16x plus 30 equals 0. Now the first step is to start by going ahead and transforming it so that c is alone on the right-hand side. So let's move c over to the right-hand side, giving us 2x squared minus 16x equals negative 30. Now we want to go ahead, so move c over. So move c is the first step. Then divide by a. The reason we divide by a always is to get a 1 as a coefficient for x squared. So let's divide by a now, and that's going to give us x squared minus 8x equals negative 15. The third step, so again, move c over, is that. Divide by a gives us that. The third step is to add. Now this is the part that's a little bit confusing, but we need to take a look and identify here that this is an 8. Well, because that's an 8, if we add a 16 here, this will become x minus 4, x minus 4. So 16, where does that come from? It happens to be double 8, but the real place it comes from is by taking half of this and squaring it. So whatever you have here, take half of it and just go ahead and square it. So half of 8 happens to be negative 4. Squared, though, is 16. So we're going to add 16 to both sides like this. And what that does for us, again, so we're going to add whatever this quantity is right here, which in this case happens to be, let's see, b over 2a, that quantity squared, to both sides. Where did I get the b over 2a? Well, take a look here. If I divide by a, remember we divided by a over here in the whole thing? This becomes b over a, but we want to add, that's what this is right here. This negative 8 is really just b over a, but I want to add half of that squared. So instead of b over a, I write it as b over 2a, which means half of this, right? This over 2 is half. So we square that number and add the 16. This gives us the equation x squared minus 8x plus 16 equals 1. And at this point in time, we're going to take a look. We're going to factor the left-hand side. Okay, factoring the left-hand side. And we're going to notice that it factors as a perfect square binomial, always. And this happens to be x minus 4, x minus 4. So we write it as quantity x minus 4 squared. And what you'll also notice is that the factors on the left-hand side will always factor into this, x plus or minus, depending on, obviously, the sign here. If the sign was a positive, this would be a positive. Since it's a negative, it's a negative. So plus or minus, depending on the situation. And the term on the right-hand side is going to be that same b over 2a. Okay, that's what it's always going to factor into. And take a look. The original b value was 16. 16 over 2a. Well, 2 times a is 2 times 2. So it's 16 over 4. So this is going to be 16 over 4. So x plus or minus 4. Well, there it is, x minus 4. So this will always factor into this. So if you ever forget what you're doing, go ahead and think back to this and think about when you took half of it. You took half of this to get negative 4, and then you squared it to get 16. Well, that step that you took to get half of this, that always appears right here. So half of this being negative 4 is always going to appear here. If this number were a number like, I don't know, say 9, half of 9 is going to be 4.5. This would have been 4.5. It will always work out that way. This will always be half of this, assuming that you got rid of the a value in the front first. And then the final step here is to go ahead and solve for x. I'm just going to put solve, okay? So here our steps are kind of out of order here. This went to really step 4, and this was really step 5 here. Okay, because this was all going to there. So we factored that, and now we need to solve. So let's go ahead and solve this. We're going to take the square root of both sides, giving us x minus 4 equals plus or minus the square root of 1, which is just plus or minus 1. So x equals 4 plus or minus 1. Well, what's 4 plus or minus 1? That just means x could be 4 plus 1, or x could be 4 minus 1. So either x is 5 or x is 3. So the roots of this equation are x equals 5 and x equals 3. Well, we could have checked that from the start just by factoring, and I did this on purpose for this one so we could see that we could factor it. So if we divided everything by 2 to start, we'd have had x squared minus 8x plus 15 equals 0. And what you'll notice right away is that this factors into x minus 3, x minus 5, so this is our way of checking because this one happens to be factorable, and that gives us roots of 3 and 5. So if our problem that could be factored, obviously wouldn't go through this whole method, but we're just showing that we get the same answers over here that we had by using completing the square as we get from using a factoring method. If factoring is possible, we would do it that way. Example 3 says solve x squared plus 6x plus 13 equals 0. So let's go ahead and move the 13 over right away. Let's take half of whatever well, there's no a term here, so we don't have to divide by a. There's nothing to divide by. Let's take half of that 6 and square it. Well, half of 6 is going to give us 3. Squared is 9. So we need to add 9 here and add 9 here. And this makes sense because now this factors into x plus 3, or x plus 3 quantity squared. And over here we get negative 4. Square rooting both sides, we get x plus 3 equals plus or minus the square root of negative 4, which is really just 2i. We did this one before. That's x plus 3. We did something like this before, So this just becomes plus or minus 2i. Subtract the 3 from both sides by putting a negative 3 in front. So x has solutions that happen to be complex conjugates. We'll talk about what the significance of the fact that this is a complex conjugate as opposed to a real number when it comes to looking at this solution graphically later on in different sections. In the final example, solve 2y squared plus 5y minus 3 equals 0. Let's go ahead and add the 3 over to the right-hand side. Let's divide by 2. It's going to be a little bit messy. Now we have to take half of the resulting value here and square it. Well, half of 5 halves is 5 fourths. The way you can have this very easily is by introducing a 2 factor in the denominator, making this 5 fourths. So again, half of this is 5 fourths. Squaring 5 fourths gives us 25/16 added to both sides. And then it's important to remember that this factors into y minus whatever half of this is, or plus whatever half of this is, squared. So y plus 5/4 squared equals, and then we have to add these two fractions together with a common denominator. Common denominator in this case would be just 4, or 16 rather. Yeah, 16. So if we go ahead and make these both 16, it's going to become multiplied by 8, 24 over 16. 24 plus 25 is going to be 49 over 16. And then finally take the square root of both sides, remembering that it's plus or minus the square root of 49/16. So the square root of 49 is 7, square root of 16 is 4, so it's really plus or minus 7/4. Again, because we're square rooting both sides like this. Now I need to subtract 5/4, so y equals negative 5/4 plus or minus 7/4, which we can then split into our two different answers. So negative 5/4 plus 7/4 and negative 5/4 minus 7/4, giving us final answers in this problem of, this is going to be 2/4 or just 1/2. That's one of the answers. All right, reducing those. And this is going to be negative 12 over 4, or simply negative 3. And you can check that these answers are right because this equation happened to be factorable, and it factored into this. And this is where the negative 3 comes from as a root, and if you solve this, you're going to add 1 and then divide by 2. That's where the 1/2 comes from here.